Hello, in this video I'm going to present and explain a very nice property of triangles which is as follows. The heights of triangle intersect in one point because of Jacoby identity. This expression was made by a mathematician Soviet named Arnold, and the proof was made by another Soviet mathematician named Kudaverdyan. His proof is on the web, and you can go and see his proof. Here I'm going to present his proof as simple as possible. We have a triangle ABC with three sides A, B, and C. And then these sides A, B, and C, if we see it as vectors, then we have the expression, the obvious expression, A plus B plus C equals 0. Before I proceed, I'm going to give you a quick reminder of vector and triple vector product. For two vectors A and B, the vector product is A cross B equals minus B cross A, and for the vector triple product we have this expression A cross B cross C equals A dot C times the vector B minus A dot B times C. See that if C is B, then A cross B is equal to 0. But if we put A equals to B, then B cross C is not equal to 0. The Jacoby identity for three vectors is as follows. A cross B cross C plus B cross C cross A plus C cross A cross B is equal to 0. And if we determine the first item with capital N and sub A, the second one capital N B, sub B, and the third capital N sub C, then their sum and A plus and B plus and C is equal to 0 because it is the same Jacoby identity with another notation. Now, you have here our triangle in three dimensions. Here is A, B, C, the side C and B, and the cross product B, C is this vector. And the cross product of A with this vector is the vector NA, which is applied to the point A, and it is perpendicular to the line to the side BC of the triangle. But this is also the height of the triangle from the point A. Therefore, H sub A is equal to A plus a proportional vector of the vector NA. The same applies also for the rest. Now we are going to the page 2, where I'm going to prove this very nice expression, which is as follows. Let's select a random point M on the plane of the triangle and connect this point M with A, B, and C. And let's call the first one MA by the letter X. Therefore, the second vector MB is equal to X plus C, and MC is equal to X plus C plus A. And we write these three vectors here. Now, we formulate the equation MA cross NA plus MB cross NC plus MC cross NC, and we will prove that this equation is equal to 0. For this purpose, we replace MA, MB, and C with the corresponding expressions X plus C, X plus C plus A. And if we put if we make the calculations, we can gather the cross product of NA and B and C with X. We have finally this expression here, which is equal to 0 because this NA and B and C is the Jacoby identity. We have only these two items. Here the two items have the vector C, and we replace this vector C by the corresponding expression with A and B, which is minus A plus B. And the C plus A is minus B. Therefore, we have here the expression A plus B cross NB minus B cross NC. Now let's put the corresponding expression of NB and NC here, and we have this expression with again appear the vector C, which must now replace it by the other two A and B like this. But now we have also introduced another minus sign, and therefore we have a positive sign in the final expression. Now B and A, if we multiply B and A with A cross product A, we don't have the A cross product A, and therefore this expression becomes now here A plus B dot cross product B cross product B and cross product A, and the same is applied to the other item. Now if we raise the parentheses here, and we have the A cross product with this expression and the B with another expression, we have this. And for the second item, we have another two items with the same technique, but these two items are opposite to one another and they cancelled simultaneously. Therefore, you have A cross B cross A cross B cross A plus B cross A cross A plus cross B, and now we add and subtract the expression B cross A cross B minus the same. Now if we call the pseudo vector B cross A K, this is minus K and this is K, and therefore this expression here becomes A cross B cross K plus B cross K cross A, because now the minus becomes positive because we have reversed the cross product here, plus this expression which is K dot the cross product A cross B minus this one. But this is Jacoby identity, and therefore we have finally this expression which is obvious equal to 0, and it is proved the expression we have said before. Now, in this third and last page, I'm going to apply the previous equation with another convenient point here inside the triangle. Let's say that these three heights are not intersect in one point, but in three, like this. And let's choose this one as the point M. Therefore, the previous expression, which is equals to 0 in this one, but MA is a fraction of HA, which is obviously collinear with NA, as we have said before. Therefore, this expression is 0. The same applies for HB. And finally, MC cross NC is equal to 0, which must be MC proportional to HC, and therefore the 3 points coincide in only one. And the proof is done. Thank you very much.